Consider the weighted voting system. Q, so the quota is unknown. Then you have a player number 1 who has 9 votes, and a player number 2 who has 5 votes, and a player number 3 that has 1 vote. Which values of Q results in a dictator? List all possible values. So with this problem, there's 2 things that are very helpful. And that is that we remember that the quota cannot take on any value that it wants to. Like, so, like 10,001. Could the quota be 10,001? No, it couldn't. And remember the the little formula that I gave you for the quota, and that is that the quota has to be Q has to be between, so let's let this be V. Let V be the total number of votes. So that is so that is 9 plus 5 plus 1. So I added the weight of all the players. That equals the total votes of that voting system. And that is 9 plus 5 is, well, 9 plus 1 is 10, plus 5 is 15. So that's 15. Okay. So the quota has to be less than or equal to 15. And I'm going to write, or in general, it's less than or equal to T or V if you let V be the total number of votes in the weighted voting system. In our situation, Q must be less than or equal to 15. And it has to be greater than or equal to half of the votes, the total number of votes. So half of 15, so to calculate that, 15 over 2 is, okay, so if this was 16 divided by 2, that would have been 8. So 15 divided by 2 is 7.5. And of course, the quota can't even be like 0.5. So we're going to have to see, it has to be strictly greater than 7.5. So it couldn't be 7. So we're going to round that to 8, the largest. Hold on. No, hold on. I'm going to leave that 7.5. And that means that now I'm going to list the range of numbers that Q could possibly take on. What are the numbers between 7.5 and 15? And it only makes sense because nobody has, in this weighted voting system, nobody has like 1.5 votes. Everybody has a whole number amount of votes. So really the first value that Q can take on is 8, because the first whole number greater than 7.5 is 8. Then it could also take on 9, 10, 11, 12, 13, 14, or 15. Those are the values that the quota could take on. And they seem like a really long list. I've done a separate problem, and it wasn't nearly as long. But the first question here, so that's what we used first. We used that formula, this formula. Let me get my pointer. To narrow down what the possible values of Q can be. Now, because we only have 1, 2, 3, 4, 5, 6, 7, 8 different values for Q, we don't have, we're going to use the process of elimination, which means we can just guess, is Q 8 here? Does it meet the requirements? If the quota is 8, does it meet the requirements for this problem? And we're just gonna, if the quota is 9, does it meet the requirements for this problem? So we're just gonna guess and check, and the ones that don't work, we're gonna be crossing off. And the ones that do, we're gonna list as the answers. So it says, which of the Q results in a dictator? So let's look at 8. If I'm replacing the Q in this weighted voting system with an 8. Is there a dictator? One person who has enough votes all by themselves to pass a motion? Certainly. Yes, there is a dictator. It's this player number 1 is a dictator. So we're going to list 8 as one of the answers here. And what about 9? So I'm going to write the quota is 9. Is there a dictator there? Yes, there definitely is, because like the player number 1 has exactly the right amount of votes to pass the quota, because it meets the quota. So yes, 8. And when you have a value of when the Q is 8 or 9, then you definitely have a dictator. Yeah. Let's see what happens when we try 10. Let's just see, does 10 result in having a dictator? Oh, and I'm replacing the Q with 10 in the weighted voting system. So does anybody have enough votes by themselves to pass the motion? And the first player has the most votes, so they're really the ones we're focused on that might be able to be a dictator. And they don't have enough to pass the motion by themselves, so they're not a dictator. So if the quota were 10, there would be no dictators. And certainly the people with smaller points would not be able to pass a motion by themselves for sure. So the answer to this part is just 8 and 9. Next, they asked us, what is the smallest value for Q that results in exactly one player with veto power who is not a dictator? So thinking about this for a moment here, the person who's going to have the most amount of power in this weighted voting system. So again, this weighted voting system, and the person who has the most power and who is most likely going to have veto power is the player number 1. And in fact, if player number 2, it ended up being that player number 2 has veto power, then player number 1 would certainly have veto power, because if you can walk away with 5 points and you're not going to pass the motion, then if you walk away with 9 points, you're definitely you're definitely needed as well to pass a motion. If you need those 5 points to pass a motion, then for sure, if someone who has 5 votes is needed to pass the motion, then certainly someone with 9 votes would also be needed as well. So really we're looking here at when this player number 1 has veto power. So let's just focus on that. So I'm going to go through, and we've already said player number 1 was a dictator with the situation of the quota being 8 and quota being 9. So those are not answers here, because it specifically says when they're not a dictator. So we can say, and I'm using process of elimination. I'm just going to go down and I'm going to guess and check, right? So we already know that the 8 was wrong and 9 was wrong. And And you guys see how there's not very many numbers on this list. So we're not going to be here all day. We're going to be here for a while, right? But we're not going to be here all day. We can use this guess and check method when there's a limited amount of answers, right? Like if you're working a multiple choice test and there's only 4 different answers, you can guess and check each of those 4. And as you figure out, oh, A is not the answer, then you cross it out. And now you have to choose between B, C, and D, right? So we're eliminating the wrong answers, and that's going to help us get to the correct answer. So that's that process of elimination. So what is the smallest value that for Q that results in exactly one player having veto power with veto power who is not a dictator? So let's start with 10. Let's guess and check. We say, okay, what if 10 is the quota? Then in this situation, if I take away, let's just take away player number 1. And reminding ourselves of the definition of veto power. Veto power means that if this person walks away, the other people all together cannot pass the motion. So let's say we take away player 1. And I add together the rest of the players' votes. That's 5 plus 1, which is 6. Can we pass the motion with only 6 people? No, we can't, right? So this player 1, it does have veto power here. And we know that 8 and 9 would not work. So this is the smallest value. Because we can try, our next thought would be, okay, well, let's see 11 and see if 11 also, if not, if player 1 is also has veto power when the quota is 11, but they're asking us for the smallest value of Q. So even if we knew that 10 and 11 were both quota that met these requirements, we would still want to choose 10 as the answer because 10 is the smallest quota that this is true for. So our answer here is 10. Okay, then they say, what is the smallest value of Q that results in exactly 2 players with veto power? So let's just see if 10 works for that as well. So we already know that player 1 in this situation has a veto power. But what if I take away player 2? Let's see. If I take away player 2, then the 9 plus 1 is 10. And so they're able to pass a motion without player 2. So player 2 does not have veto power. And we're not going to really talk about player 3 having veto power or not. I know that it's going to be player 2. I mean, player 2 is going to get veto power before player 1 gets veto power because they have more votes. So 10 is not the answer. So I can cross off 10 as being one of the solutions. So let's try the next. Let's try 11. If I cover up 9 here, will they have veto power? So then 5 plus 1 will be 6, which is not big enough to pass a motion because we need 11 to pass a motion. So 9 still has veto power. Now, if I cover up player 2, and with looking at the rest of the votes, there's 9 plus 1 is 10. And that is not enough to pass a motion. So they do absolutely need player 2 here. So player 2 does have veto power here because without them, they can't pass a motion. Just double checking. And what about player 3? I mean, we don't need to know this, but if player 3 walks away, then there's 9 plus 5, which is 14 votes, which are able to pass the motion. So player 3 here does not have veto power. So the only two people that have veto power are player 1 and player 2. And that's exactly 2 players with veto power. That would have been a problem if player 3 had veto power, because they say exactly 2 people have veto power. So in this situation, we have exactly 2 that have veto power. So I'm thinking possibly, and there again, they're asking for the smallest value. So it could be that if we tried 12 as the quota, it could be that it also has exactly 2 with veto power, but then we would have 2 answers, 11 and 12, and they want us to get the smallest of those answers. So our answer here is 11. And there we go. All right. Please let me know if you have any questions. And that is this problem. I hope you have a great day and take care.